The square brackets here means that you can also set a group, but you don't have to using shown. And that's how you can use it. And you can also use CHDRP if you want to set group ownership. Then we have the permissions overview. So you have read and write and execute. Read has 4, write has 2, and execute has 1. And what does that mean? Well, we have just seen me using commands like chmod 600, in which 6 is read and write, and 00 is nothing and nothing, of course. Why do we do 600? Well, because permissions are assigned to user, group, and others. And if you use chmod in a so-called absolute mode by using these numbers, you are using 3 digits to set the permissions for these specific users. So that's what 660 and that kind of stuff is all about. About the meaning of permissions, read means you can open the file, write means you can modify the file, and execute means you can run the file on directories. Read means that you can list files and directories. Write means that you can create and delete files and subdirectories. And execute means that you can change directory. Now, there is something that I want to show you. And that's the following. I am root, okay? Well, I'm not root now, but now I'm back in my root shell. And being root, I'm going to use touch/home/linda/root file. I'm opening a shell as usual Linda. And I'm using ls-l. And what do we see? We see a root file. Now, my question, folks, and I want you to answer yes or no in the group chat, is this going to work? rm-f on root files. So can user Linda remove the file in her home directory, which is owned by user root and by group root, and to which only user root has write permissions? Can you please say yes or no in the group chat? Is this going to work? Yes or no? I'm waiting a little bit to see if any answers are coming in. But this is an important question for your understanding. And I'm getting yeses. I'm getting more yeses so far than no's, but I only have 4 answers. And now we are about equal amount of no's, and I'm guessing the no's are on the winning hand. And let's check it out. Is this going to work? Yes, this is going to work. Why is this going to work? Well, ls-ld on dot. Linda is in her home directory. In her home directory, Linux has write permission. And the write permission allows you to delete files from the directory. The issue here is if you want to be able to delete a file, you need to look at the directory permissions. File permissions are not important for deleting the file. Directory permissions are important. And that is why user Linda can delete a file even if she can't read the file. The write permission on the directory. In this case, she could read the file. I was too lazy to modify it. But even without a read permission for others, user Linda would perfectly be able to delete the file from her home directory. All right, we talked about managing permissions. chmod is the main command you are going to use to manage permissions, and you can use it in absolute or a relative mode. Absolute mode is where you use the digits. Relative mode is where you use a command like chmod plus x. So here on the slide we have 2 examples. chmod 750. 750 corresponds to Hugo, user, group, and others. User gets 7, group gets 5, others get 0. What is 7? That is read plus write plus execute. 4 plus 2 plus 1 is 7. What is 5? That is read plus execute. And what is 0? Well, that's obviously nothing at all. You can make it easier if you want to quickly set a specific permission. Just use chmod followed by the permission, like chmod plus x, to make your script executable. By default, the result will be that every entity that has read permissions would also get execute permissions in that case. You've seen me doing that when we created the script. Good. Then we have a very special thing. They call it Special X. Sounds like a James Bond movie, Agent Special X. What is the problem? Let me show you the problem. And I need a couple of commands, so please pay attention because it's so much easier to demonstrate what is going on. I'm going to use mkdir -p /data /students. And I am going to use touch /data /students /1.9 .txt ls-l /data /students to verify. SJ, we are not there yet, so I'm ignoring your questions so far. So ls-l /data /students, and here we can see a couple of files, and I'm also creating mkdir /data /students /22 0.4. I need some subdirectories. ls-l again, and here we can see the subdirectories. Now, the subdirectory is kind of boring, is set all right. Let's configure some subdirectories the wrong way. So I'm getting into data students, and I really need to make an effort to demonstrate what I want to demonstrate, but I do want to demonstrate it anyway. I am going to use chmod 660 on 22 whatever. And ls-l, and oh my goodness, here we can see that the directories have been configured the wrong way. So what can you do about it? Well, I am going to use chmod +x -r for recursive +x on dot. And what is the result? Well, oops, ls-l, the result is this. And what is there not to like about this command? Have a look at what I just did and why we should not like this at all. Well, there's a pretty obvious reason. I use chmod +x to change the permissions on the subdirectories, but I also got the execute permissions on all files. And that is because that's exactly what I was asking for. So that's not what we want, and that's an easy fix. I'm going to use -x to remove it, and I'm going to change it into special X plus uppercase X. And now I'm using ls-l, and what do we see? We see that the directories have obtained the execute, the files have not obtained the execute. That is special X. And good. I hope this makes sense. Now let's have a look at the slide. So when X is applied recursively, it would make directories as well as files executable. That's what we have just seen. And files should never become executable without you specifically wanting them to be executable. So that's very dangerous. And that is why in recursive commands you should use uppercase X. And we call that special X. And special X makes that the directory will be granted the execute permission, but files will only get execute if it is set already elsewhere on the file. That doesn't really make sense. So let's remember this as use uppercase X if you recursively only want to apply it to directories and not to files. All right. I don't think I'm going to run this demo anymore because we already know about it. I need to tell you about shared group directories and the permissions that apply. And SJ, you need to listen carefully because I have some news for you about the sticky bit. Your understanding about sticky bit is not correct. So listen carefully. Shared group directories. What is going on with the shared group directories? If members of the same group need to share files within a directory, some special permissions are required. And that is because if a user creates a file, who becomes owner? Well, the user becomes owner and the primary group of the user becomes owner. So if user Linda, who's a member of the group students, creates a file in the students directory, then the file will be owned not by the group students, but by the group Linda. That's not what you want. And that's what you can fix using set group ID. So using set group ID ensures that all files that are created in the shared group directory are group owned by the group owner of the directory. I first want to tell you about it, and of course I'm going to show you in a minute. I also need to talk about sticky bit. Sticky bit permission is a special permission that ensures that only the user who is owner of the file or the directory that contains the file is allowed to delete the file. SJ, this is the part that you are missing. If a user is an owner of the directory, then the user can delete the file. SJ, you are mentioning if we add T permission, Linda cannot delete the file even if it's on her own home directory. That is not correct. If you are the owner of a directory, even if you have the sticky bit, as we call it, you can delete files in that directory. How do we apply? I have a demo coming up in less than a minute. First, I want to tell you about the commands. We have chmod G+S. That will apply set group ID to the directory. We have chmod +T, which assigns sticky bit to the directory. In case you want to know, can we also set this to files? Yes, but that is meaningless. It's useless. So I'm not even going to explain because you are never going to use it. Set group ID is for directories. Sticky bit is for directories. Apart from using chmod G+S and chmod +T, you can use a 4-digit number, of which the first digit is for special permissions. That would look like chmod 3770. We have a 4th digit, and if you have a 4-digit permission mask, the first one is for the special permissions, whereas sticky bit has 1 and set group ID has 2. So this command would set sticky and set group, and everything for the user owner and also everything for the group owner. Now let me demonstrate this. I am going to need, I'm going to need directory profs. So mkdir profs. I'm also going to need ownership, so chown chgrp profs on profs. Hey folks, if you see a black bar in the lower part of your screen that is hiding the commands I'm typing, move your cursor out of the media player window and the black bar will disappear. Good, ls-l, and we have the permissions. Well, I think in shared group directories, permissions should be set to 770. So now it is prettier. Group profs has read, write, and execute. Group students as read, write, and execute to their directories. That is what I want. Now I'm going to open a shell as user Anna. And user Anna is a member of the profs directory. Okay, so user Anna is using touch/data/profs/Anna curly braces 1.4. Probably you know that this will create a range of files. It creates files NA1, NA2, and NA3 and NA4. So I'm using ls-l on data profs and to see the contents. And what do we see? We see that all the files are owned by user Anna. Set group ID is all about the group ownership, and the group ownership is also set to Anna for the simple reason that when a user creates the file, the primary group of that user becomes owner of the file. Good. Now I'm using exit. On the slide you see a hash. If I'm using a hash on the slide, that is to make you know that we require root privileges here. I'm going to use chmod G+S on data profs. First, let me do ls minus ld on data profs. And there we can see that we have a little s here. Normally it reads RWX, now it reads RWS. If it is RWS, then set group ID applies. Apart from set group ID, we also have execute on the group. So what is the result? Well, the result is if I'm becoming user Anna again, and user Anna is doing a nice command to create some files again. There we go, ls minus l on data profs. And what do we see? The files that Anna just created are group owned by the group profs. And that's what we need here. All right, I'm using exit again. Now I'm going to be user Anouk. User Anouk is also a member of the group profs. Now, the interesting question, rm minus f, data, profs, NA4. Can user Anouk do this? Well, if you think about it, we are in the directory data profs. Data profs is group owned by the group profs. The group profs has write permissions. So yeah, this should be working. In case you don't like that, you need sticky bit. And I repeat, if sticky bit applies to a directory, a user can only delete files from that directory if the user is either owner of the file or if the user is directory owner. The second option, if the user is directory owner, leaves an option for users to delete files, and that's convenient for the head of the department, for instance. So the headmaster might be able to delete all files in the profs group. So if user Anna is headmaster, how are you going to make sure that she can delete all files? Make her a user owner. Then it works. But without that, let me use chmod plus t on data profs. And let me use su minus Anouk to do an Anouk shell again. And rm minus rf data profs Anna. And what do we get? Operation not permitted, all alone. And that's what we need here. I'm going to skip the slide about UMask because I think that UMask is not as important for the exam. I am going to put you to work. And I'm going to simplify this lab. Don't do part 2, only do part 1. I do not want you to work with UMask. If you're going to mess up the UMask, you will encounter lots of challenges later on in this course, so don't do that. What I need you to do seems quite simple. Create a shared group directory structure, data profs and data student that meets the following conditions. Member of the groups have full read and write access to their directories. Others have no permissions at all. And that's all that I want you to do. Because this is a combined break with lab, I am going to set the break timer to 15 minutes in total. After the break, I will present the solution for this lab, and we will make a start with the important topic of partitions. For your information, I'm not going to finish this topic of partitions. We'll continue talking about partitions tomorrow, but now I want you to work, and I want myself to meet my coffee machine, so I will see you in 15 minutes. Enjoy and talk to you in a bit.